The mysterious item known as Oumuamua, an odd cigar-shaped object from beyond our solar system, has baffled scientists since its discovery. However, the James Webb Telescope has finally taken the first-ever actual picture of this object. Its shape and its swift, erratic movements set it apart from anything we have ever seen. What mysteries of the universe does Oumuamua conceal? Join us as we reveal the breathtaking picture of our cosmic companion. The discovery of Oumuamua during its transit through our solar system sparked heated discussions among astronomers and space specialists. We now have additional evidence of the James Webb Space Telescope's existence, thanks to this image, which may aid in our quest to discover more about extrasolar objects. It might even alter our understanding of how planets form. The signals abruptly ended just as we were starting to decipher its secrets, leaving us to speculate as to whether we had witnessed a visitor or something much deeper. Oumuamua, which translates as scout or messenger in Hawaiian, was initially discovered in Hawaii through the use of a telescope. It is unique in that it is the first object known to have come to Earth from another star system. Its peculiar shape, its long and thin like a cigar, was noted by scientists when they initially began to investigate it. It also rotated in an odd fashion and moved at an unexpectedly high speed. Initially, astronomers believed it to be a comet because it lacked the typical gas cloud that comets are known for. It was never confirmed, but some even conjectured that it might be an alien spacecraft. Now that Oumuamua is clearly visible, scientists have a wealth of new information to work with. Up until now, scientists have only speculated about the possible appearances of objects from distant star systems, but this object offers a real-world example to examine. This discovery may help future space missions and technologies investigate the universe, as well as provide us with additional knowledge about how these particles form and move across space. Even more intriguingly, research on it may contribute to our understanding of how solar systems and planets arise in other regions of the galaxy. If it originated in a different solar system and was driven out due to its close encounter with a more massive object, then further information regarding its composition may provide us with hints about the composition of planets in other star systems. It might indicate that planets originate differently in other regions of the galaxy if it contains elements that are uncommon in our own solar system. Not only that, but this finding has implications for the ongoing hunt for extraterrestrial life. Although life is unlikely to exist on it, the fact that it originated in a different star system creates intriguing opportunities. These kinds of objects raise the possibility that they could transport the elements necessary for life from one star system to another, assisting in the possible expansion of life on Earth. We're coming closer to solving the secrets of the cosmos and the possibility of extraterrestrial life thanks to the James Webb Space Telescope. Worldwide scientific attention has been drawn to the mysterious traveler. More than merely a technological triumph, the telescope's ability to obtain a detailed image of this enigmatic object raised a number of new scientific inquiries. This peculiar cigar-shaped object, originating from a different star system, defies the standard classification of celestial bodies and exhibits unexpected behaviors. Not only was its trajectory through our solar system unexpected, but it also demonstrated the significance of considering space object defense for Earth. Its course was unaffected by the normal gravitational forces, in contrast to most objects in our solar system that have predictable orbits. This serves as a reminder that there can be potentially hazardous items out there that we are unaware of. The fact that the telescope was able to follow it demonstrates how important sophisticated space telescopes are for monitoring these extraterrestrial visits and defending Earth from any danger. This incident appeals to our innate curiosity and drive to learn more about the unknown, making it more than just a significant scientific breakthrough. When we see a clear picture of it, our imaginations run wild, fusing science fiction with actual science. It motivates us to continue stretching the boundaries of our understanding of space. Oumuamua's mysteries serve as a reminder of how much we still don't know about the universe and how we fit into it. But the tale is far from ended. It leaves us with more questions than answers as it travels farther through space. But it also provides new information and resources for scientists to research related objects in the future. This meeting inspires upcoming scientists, engineers, and visionaries to continue exploring the sky while also deepening our grasp of space. When Oumuamua was originally seen, experts speculated that its surface might be composed of ice or metal, but the absence of conclusive evidence left them with more questions than answers. We can now examine the light that is reflected from the telescope because of its sophisticated instruments. This aids in the identification of the precise components and mixtures that make up the object by researchers. We might either validate or refute existing theories on its origin based on the evidence. For example, it would demonstrate that planets in far-off star systems are composed of extremely different materials if it included substances that are uncommon in our solar system. On the other hand, if it resembles items that we are familiar with, it may indicate that planet formation is uniform throughout the cosmos. The possibility that it may provide information about a broader class of interstellar objects, most of which we were only aware of through ideas and models, is an extremely intriguing one. The fact that this image was taken by the James Webb Space Telescope lends credence to the theory that objects from other star systems may be more numerous than previously believed. This refutes the long-held notion that it is exceedingly uncommon to encounter interplanetary objects. Scientists may need to adjust their estimates of how frequently these things approach Earth based on a closer examination of its trajectory, speed, and interactions with our solar system. If they appear more frequently than anticipated, it may alter our understanding of the transfer of materials across star systems. After discovering these things, we shift our attention to the horizon and investigate any further mysteries that might exist in the cosmos. Unusual finds from space, these items may serve as messengers, providing us with crucial details about stars and planets too far away for direct investigation. Examining Oumuamua closely could potentially aid in the development of new methods for locating and monitoring incoming extrastellar travelers. Although moving objects can be easily observed using telescopes such as pan-stars, Oumuamua's speed and size presented a significant difficulty. The James Webb Space Telescope's ability to take detailed pictures of this rapidly moving object demonstrates that, with the correct tools, we may learn more about these visitors. This might encourage researchers to work on creating even more advanced detection systems that can monitor objects like Oumuamua as they enter and exit our solar system. These developments could include developing algorithms to identify anomalous trajectory or constructing specialized space-based observatories intended to detect fast-moving interstellar objects. We might be able to monitor these objects more frequently and do in-depth research on them with improved technology. Studying something like Oumuamua offers the exciting opportunity to get further insight into the evolution of planetary systems. Our understanding of the formation of planets is primarily based on research on our own solar system, which gives us a limited perspective of the galaxy. Through examining an item from a different system, researchers can validate and refine their theories regarding the genesis of planets. Examining its composition and structure, for instance, may provide light on the kinds of collisions and interactions that gradually sculpt star systems and planets. But there's still more. Examining the properties of Oumuamua could provide crucial hints on the initial phases of the development of the larger planetary body if it originated from one. These discoveries could improve our understanding of how planets and other things develop and reveal factors that either maintain their stability or lead to their disintegration. If components found in Oumuamua differ from anything else in our solar system in terms of structure or chemistry, that is another important topic. If true, this would indicate that a larger range of materials than previously believed are used in the formation of planets, and it would also raise new concerns about how various settings, such as proximity to various kinds of stars or massive planets, influence the evolution of planets and other celestial bodies. These are not merely theoretical questions, the solutions may have practical implications for our understanding of life as it exists in the cosmos. There may be additional areas where life can exist if planetary systems are more diversified than we think. Not only does research on Oumuamua contribute to our understanding of planetary formation, but it may also yield important new information for scientists examining the long-term history of star systems. According to a well-known idea, interstellar objects such as Oumuamua are expelled from their home systems after coming into close proximity to massive planets or other celestial bodies. Smaller objects may be forced out of the way by the gravitational pull of nearby planets and into the empty space between stars. Researchers tracing Oumuamua's trajectory aim to determine its origin and the cosmic event that propelled it into space. Knowing this is crucial because it clarifies how star systems evolve over time, particularly in their more chaotic phases when planets and other bodies begin to interact in ways that aren't predicted. Findings such as this broaden our understanding of space exploration and help us to understand how the cosmos functions. But this finding may have practical applications in addition to being fascinating for scientists. When plans for extrasolar travel begin to take shape, the pictures of Oumuamua, for example, may stimulate fresh ideas about how we may communicate with or photograph these enigmatic space travelers. Comprehending the motion of these entities in space will become much more crucial. They might provide information about how to power or navigate our spacecraft for extended space missions. Its peculiar, erratic course serves as a reminder of these difficulties while simultaneously creating a wealth of fascinating opportunities. One day, if we can improve our ability to find and track these kinds of objects, we could even be able to approach them closely enough to conduct in-depth research or retrieve samples. The theory that Oumuamua may be related to the possibility of life beyond Earth is one particularly intriguing one. Its voyage from beyond our solar system makes it a potential candidate for the panspermia theory, which postulates that life, or the fundamental components of life, may have been dispersed throughout the universe by comets or asteroids, despite the lack of direct evidence of life on it. A major contribution to the panspermia idea would be made if Oumuamua includes biological elements. Examining these substances may help us understand how life's constituents would fare in the harsh environment of space. Its peculiar spinning motion raises more questions about the forces it encountered on its journey. According to some experts, this odd movement might be the consequence of being forcefully expelled by a massive planet, such as a gas giant. The hypothesis of a rocky voyage could be supported by detailed photographs taken with powerful observatories like the James Webb Space Telescope, which could help prove this by displaying traces of impacts or craters on its surface. Not only that, but information gathered by the telescope may also provide light on Oumuamua's interactions with solar winds, streams of charged particles emanating from the sun that influence comet behavior. The mystery surrounding Oumuamua is that, in contrast to other comets, it didn't emit any gas when it approached the sun. Scientists were taken aback by this and speculate that it might be constructed of strange materials or have a shield to stop gas leaks. These revelations have the potential to alter our understanding of extrasolar objects. Having now deciphered the mysteries of Oumuamua, let us examine how this newfound understanding advances our understanding of space travel. Its fascinating thermal characteristics are also revealed. Its behavior and brightness did not alter as it approached the sun, which may indicate that it possesses unique thermal characteristics. Comprehending this could lead to a shift in our understanding of how interstellar objects respond to our solar system, improving our models of solar-wind interactions and assisting with the planning of future space missions. Who knows? We could even be able to use this to find possibly livable locations outside of our own system. With the use of imaging equipment, scientists can examine things like Oumuamua and learn more about how it absorbs and releases heat. This can provide us with information on its composition, structure, and whether or not it contains any materials that changed instantly from solid to gas when it approached the sun. The manner in which Oumuamua manages heat is particularly intriguing, as it may provide insight into the conditions it encountered on its space voyage. If it appears to have retained heat for a longer period of time than anticipated, for instance, this could indicate that it originated from a warmer region of its original star system, perhaps near a star or planet with a dense atmosphere. However, if it is poorly able to transfer heat, it may be composed of well-insulating materials, such as ice or porous rock, which may have contributed to its survival throughout its protracted voyage across the icy void of space. Researchers may be able to learn more about the formation and evolution of items such as this one by examining how it responds to heat. A large amount of ice on Oumuamua may indicate that it originated in a frigid region of its home star system, when the temperature was low enough for ice to form. This would lend credence to the theory that the gravity of massive planets frequently pushes interstellar objects out of their systems. However, if the majority of Oumuamua is composed of rock, this could indicate that it developed in a hotter region and that it was propelled into space by a spectacular event, such as a close encounter with a large planet or star. The capacity of the James Webb Space Telescope to take a photograph of Oumuamua may aid in our investigation into whether or not it possesses any magnetic properties. Its ability to traverse through time may have exposed it to magnetic forces that altered its spin or movement, however this is still unknown. Scientists may be able to determine whether and to what extent Oumuamua has a magnetic field by observing its interactions with the solar wind. If it does, this may provide crucial information about its composition and the forces it has encountered on its voyage. Finding these items could provide light on the formation of objects from other star systems and raise the possibility that they may even transport components necessary for life across great distances in space. With the help of the James Webb Space Telescope's strong instruments and the discoveries discovered concerning Oumuamua, questions regarding the interaction between stars and planets on a far bigger scale may also be answered. Astronomers were granted a unique opportunity to observe the flow of materials between star systems when the James Webb Space Telescope took the picture of Oumuamua. This occurrence demonstrates how matter can be forced from one star system and transported across the immense void of space to another. Around billions of years, this process has shaped galaxies all around the cosmos. Significant occurrences including as supernova explosions, stellar winds, and comet and asteroid motion cause star systems to lose material. Afterwards, these elements may combine to form new star systems, which will aid in the formation of planets and other space objects. Scientists are learning more about the mechanisms underlying these exchanges and their impact on the universe by closely examining Oumuamua. The telescope's finely detailed images represent a significant advancement in astronomy, revealing not only the unique characteristics of Oumuamua, but also providing a deeper knowledge of the larger-scale functioning of space. These new data may lead to important discoveries that alter our understanding of the cosmos. The possibility that Oumuamua contains complex organic compounds is an intriguing theory. The idea that comets, asteroids, and other objects traveling between stars could be the means by which life, or the elements necessary for life, spreads throughout the universe has long captivated scientists. Although it's improbable that Oumuamua includes life as we know it, it's an intriguing hint that it might contain amino acids or other ingredients necessary for life. It suggests that the elements of life might be shared by all objects in the universe. Examining Oumuamua may also contribute to our understanding of how celestial bodies disintegrate or are destroyed. The genesis and evolution of planets and other space objects may be better understood by scientists with the use of this information. For instance, Oumuamua's composition may provide crucial information about how such occurrences take place if it is a fragment of a larger item that broke apart while traveling. Researchers can gain additional insight into the inner workings of objects traveling through space if they determine if Oumuamua is composed of solid rock or a combination of smaller components. Scientists may be able to learn more about the origins of Oumuamua and the early stages of its home star system by investigating its origin. Some theories propose that the gravitational attraction of massive planets pushes objects such as Oumuamua out of their star systems. Analyzing its composition may reveal whether it was expelled from its initial system by a collision or whether it had near interactions with large gas planets. Its surface may indicate interactions with molecular clouds, the environments where young stars are created, if there are signs of dust rich in organic material. This could provide light on significant chemical reactions that may have contributed to the origins of life. How do you feel? Could Oumuamua and other similar items be alien spaceships masquerading as earthly celestial bodies? Explore this cosmological enigma, offer your opinions, and don't forget to like and subscribe for more content.